Right. So what are they talking about here?
Okay.
So here we've got the graph of y equals the function g of inputs x. So for any input x, we'll have one definite
Mm.
output value y from doing the g stuff. And what is the g process? It's in two parts. So although this is a real headache at first to get to grips with, that curly brace there and the apparent complexity, it is what's happening with the modulus function, the absolute value, where you just take the positive version of any value. You're also saying, well, it's going to be this situation for these values of x. For example, x value is less than 2. In other words, x values on the x-axis west of 2. And it's going to be a different story for x minus 7 specifically here. For x minus 7 is the story that's happening for x values east of
4x
an x
7.
value of 2. East of 4x. No, 4 is, I mean, that's a typical straight line equation, isn't it? 4x minus 7.
No, I was just saying it's 4x minus 7, because I thought you were saying it was x minus 7.
Oh, sorry, yes. Oh, do correct me if I say, and again, that might be the audio cutting out, or it might be one of my frequent verbal typos. And do let me know. But so 4 would be the what of this part of the story?
The gradient.
Good. And y, and I beg your pardon, minus 7 is the
y-intercept.
And you can see where that would be happening down at minus 7 on the y-axis, sorry.
Yeah.
Only this story, 4x minus 7, is only happening from an x value of 2 onwards. So we don't actually see a y-intercept for that.
Right. Okay, yeah.
And then for this part of the story, before x is 2, we've got this. What form of expression is this? What kind of expression is that?
That's in its completed square form.
Oh, of a quadratic, exactly, yeah, good. Right, so first question, find the value of GG of 0. And do you know to interpret that? How would you interpret that? Oh, did I, by the way? I didn't, did I? Yeah, I did, good. How would you interpret GG of 0? What's another way of saying it? Or can you explain it? All right. But it just brings you back automatically, does it?
No, I had to just reconnect to the Wi-Fi quickly.
Right.
Enjoy.
The same link works, doesn't it? Sorry, yeah. So I was just putting you on the spot here with GG of 0. How would you read that?
I'm not 100%, but what I think you do is, so you put 0 into one of those equations, and then you'd put the other equation into where, then you'd figure it out, and then you put you put one of the equations into where x is in the other equation.
Yes, I think you're talking about the right thing. I mean, I can interpret what you're saying in the way I like. I'm not sure if it's what you mean. It is definitely putting 0 into the x place. Here or here, we're not sure, and we suspect it might be both or something. But we'll find out as we go, because we're saying, let's do the g stuff to the result of already having done the g stuff to 0. So we'll do it once. We'll go from x, do the g stuff, and we'll get g of x. Do the g stuff again, and we'll have g of x.
Yeah.
So if we do that to 0, what's g of 0? Well, we have to look at which one of these to use. In other words, which part of the domain are we in? This part or that part?
We're in the first part.
The first part of the domain, that's right. So we have to plug it in here. And what do we get?
We get -2 squared, which equals 4. 4 plus 1, 5.
Good. And then just do the same, because we're going again. But this time, yep.
The same equation or the other one?
Well, this time our x value is 5. So which part of the domain are we in?
The second one.
Are we east or west of 2? It seems to be the critical question.
We're the bottom equation.
Yeah. This time we're using that straight line function, 4x minus 7. So
yeah.
What?
So that's 20 minus 7, which is 13.
Yeah. So that's that for 2 marks. Find all values of x where g is greater than 28. It's best to probably think about this graphically first, isn't it? How should we represent this on the graph? This question. For which values of x is the g function giving us values greater than 28?
We don't need to know what what equation it is out of the 2, do we? Because it will just be, I'm guessing it's just going to be the 4x minus 7 part.
No, we do have to worry about it. We don't know yet. I mean, we're going to have to consider both parts of it. We'll see how that is and how it helps to think of it graphically. If we make sure we understand, you know, what's the graphical interpretation of this question? Which values of x is g of x greater than 28? You see, what I want to make sure is that...
Oh yeah, it's on the y-axis is above 28.
Exactly, yeah. G of x means the resulting y values we get from doing the g stuff. Y is equal to g of x. So where is y greater than 28?
Yeah.
Yeah. In other words, so how shall we, what could we draw on the graph that would help?
A line at 28 on the y-axis.
A line at 28 on the y-axis? Can you just clarify that?
A line going like sideways, parallel
sideways,
with the
parallel to the
x-axis.
X-axis, exactly. What's a good word for parallel to the x-axis? Beginning with H.
Gradient of 0.
Yeah, that's brilliant, and it's true. But what's, of course, is a good word for parallel to the x-axis, beginning with H? O.
Horizontal.
Of course, yeah. We might as well call it that. So, can I do a better horizontal line than that? Could if I do that, can't I? So if that's y equals 28, yeah?
Yeah.
So what we're asking is, where is the g curve, if we can call it that? We might as well. It's a kind of a curve. Where is that? So can you interpret that graphically? What are we asking about this now?
Where is the line above that curve?
Yes. No.
Where's what y values?
Well, for which values of x are the y values?
Yeah, so okay, so
28?
So it'd be like right of that, so left of the first intersect on the x-axis and right of the second.
Exactly, yes. Yeah, I mean, I think you meant, I had to question your way of putting it. I think you said where the line is above the curve.
The line's above the other line.
Yeah, you meant above the horizontal line.
Yeah.
Where the curve line is above the horizontal line, yes, I can buy that. So it's where this G curve has Y values greater than the Y value of the Y equals 28 curve.
Yeah, exactly that.
Or line. Great. Right. So do you see how then we just have to, again, just as we ended up having to choose between these two stories earlier on at different parts of that problem, same again here. We're going to have to choose between different versions to find these 2 points of intersection.
Yeah, well, I mean, for those two, well, the first one you've got a quadratic, so it's going to give you 2 different answers, and then you just pick the negative one.
That's right. You got the idea. So, I mean, the nice thing is we can forget the fact about the limitation while we're doing it, and then adjust for that. That's what you're saying. Yeah, no, great. Carry on. You're doing good.
For the first one, you'd set Y equal to 28, and then you'd rearrange x minus 2 squared plus 1, and you're going to get 2 values, and then you can figure out it will be the lower one.
Okay. You said set Y to 28.
Yeah, set that equals 28.
And then do something with this. Ah, right. I want to know what this is equal to.
28.
28. Good. Good.
And then you could say x minus 2 squared equals 27.
Yeah, that's fine. Why am I bothering to expand it? You've got the better idea. We'd only want to complete the square to solve it anyway. Great.
Yeah, and x minus 2 equals root 27.
There will be plus or minus versions, but you've already flagged this, haven't you?
Yeah. And then x equals plus or minus root 27 plus 2.
Yeah.
And then, well, one of those is going to be a positive result and the other one's going to be a negative. So it will be x equals minus root 27.
Yeah.
Plus 2.
That's right. This x value here is 2 minus root 27.
Yeah.
Good. And then this x value?
And that x value will be set 4x minus 7 to 28.
4x, yeah. I don't know why I'm doing it down there. Maybe here would be better. 4x minus
4x equals 35. X equals 35 over 4.
Absolutely.
Equals 8.75.
Yeah. So what's our answer for part B?
Our answer for part B, find all the values of x for which y is, okay, so it would be smaller than minus root 27 plus 2 and larger than 8.75.
So like that?
Yes.
Well, I mean, that's literally what you said, but I think you meant x is less than.
Yeah. I did mean it. X.
And then you want to say x or x is greater than, or and x is greater than, it doesn't really matter.
And x is greater than 8.75 or 8 3/4.
Yeah. However you want to express that. Great. The function h is defined by the same quadratic for x values, again, less than 2.
Is there no way of you writing that in one line, the answer to the previous question?
Not in one overlapping, that's a good question, because it's tempting, isn't it? Because if the x values were between those two values, we would join them together and say 2 minus root 27 is less than x, which in turn is less than the other.
Yeah.
But because x is on over here and over here instead, that's just not an option. Nobody's invented a neat combination like that. You have to use the word or and, really, or a comma to separate them. But you need 2 bits, no. 2 pieces. Right.
Okay.
Let's see then. The function h is defined exactly like the first part of function g.
Yeah.
So it is literally, I mean, the graph of h would just be that much of the graph of g.
Yeah. Yeah.
It's implied, of course, that it goes off forever in negative x and positive y directions.
Which g is it talking about?
G is still g. Oh, I see. Well, yeah. Oh, hang on. G is still g. So it's got G's got 2 parts, but h is just the first part of g. That's all.
Okay. Well, h has an inverse, because it's just one line equation, isn't it? Like, you can inverse that one line, but you can't inverse like an unsymmetrical line, which has 2 different.
You can inverse an unsymmetrical line. When you say unsymmetrical, you might be aiming for the right thing, but it's not symmetry. What you can't inverse is a relationship between x and y coordinates, which is not one-to-one. That's the phrase you volunteered yesterday, one-to-one, when we were discussing functions.
Yeah.
Because if it's not that this isn't a function, this has only got one y value for each x value. There's no other y values anywhere for that same x value, so that's okay. But it hasn't got an inverse. The inverse would have more than one, because it would be a direct result of this having more than one x value for one y value.
Yeah.
So when you switch that round, you would have that situation, which is illegal.
Yeah.
So the short answer is that G is not one-to-one.
Yeah. Okay.
You know, it's a tricky business, that. I mean, I wouldn't normally just leave you with the phrase one-to-one and hope that was crystal clear.
No, I understand.
But you used it yesterday, didn't you? So.
And
Yep.
Well, yeah. I mean, is it the fact that it's just not one-to-one, or is it that it's not really like, it's not really a 2-to-1? Is it 2-to-1? No, it's not.
It's 2-to-1. for many values of y, yes. There are many pairs of x values that go to one y value, aren't there? Like this pair of x values goes to the y value of 28. Both of these x values have got 28 as a y value. So that's 2 to 1 in that sense, yes?
Yeah.
Which is fine. This doesn't stop it being a function. If it had an x value of 28 going to 2 y values like that, and that is what's going to happen with the inverse. You're going to have an x value of 28 giving 2 y values.
Okay.
So many to one, many inputs to one output is allowed in a function, but one to many, one input to many outputs, which is what's going to happen with the inverse, is not allowed.
Right, okay.
So the only kind of function, even though many to one is okay, the only kind of function whose inverse is also okay will be a 1 to 1.
Right,
So
okay.
the kind of function which has an inverse has to just carry on in some manner or other, going down all the way. We call that a decreasing function for obvious reasons. Or it has to carry on in some fashion going up all the way. If at any point it comes down again, then you can't invert it because the inverse will be 1 to many.
So does a parabola not have an inverse?
Exactly. Yes. In fact, we found that, didn't we, yesterday, recently? We did. We discussed with this one here. We were discussing how the reason they had to cut off half of this parabola was so that it was a function.
Oh, yeah.
That y equals x squared is a many to one function. So that's exactly why its inverse needs cutting in half, or it won't be a function. Or rather, you can't find an inverse of the whole of a parabola. You can only find the inverse of half a parabola. A part of the parabola which is increasing or decreasing all the way.
Yeah.
And not going up again or down again.
Okay.
So increasing or decreasing. Meaning 1 to 1, basically. Right. Oh, good. I'm glad we cleaned that up because that's worth understanding. And I was about to brush anyway. Right. Solve the equation h. Now, of course, h to the minus 1 doesn't mean 1 over h, does it? It probably should, but it doesn't. Okay. What's it mean?
It means I'm not sure.
Well, what about sine to the minus 1? What does that mean?
Sine to, well, when you've got, that means all of it to the minus 1, doesn't it?
Well, so it should, but it doesn't, does it? When we say sine to the minus 1, we don't mean sine x to the power of minus 1, which is 1 over sine x, do we? We should. That would be a more consistent use of the notation.
Right.
But what do we usually mean when we say sine to the minus 1?
I thought that's what it did mean.
No. No. When you press, there's a button on the calculator, isn't there? Sine to the minus 1.
Yeah.
And of course, what do you call that?
Inverse.
Inverse. Right. Now, the thing is, you might be, you might think here, well, surely that is an inverse. I mean, 1 over is a kind of inverse, but it's a special kind of inverse called, what's the proper word for 1 over?
Reciprocal.
Reciprocal. Power of minus 1 interpreted as you expect to interpret a power of something, means reciprocal, 1 over.
Yeah.
But sine minus 1 on the button on a calculator is finding inverse sine, which is not reciprocal. No. Inverse sine means please find us the angle which has this sine ratio. So
yeah.
Inside the calculator is a list or two columns, a list of angles. Pardon me. 39 degrees, 40 degrees, and so on, and a list of sines, which are I don't know, 0.6, 0.61, things like that. To get from the angle to the sine ratio is sine of whatever the angle is. To get from the sine ratio to the angle is the inverse of that. It's just going backwards.
Yeah.
It's nothing to do with the reciprocal, though. You see. But reciprocal is a kind of inverse. Reciprocal is the inverse of multiplication, isn't it? I mean, it's dividing, basically. If you multiply by a reciprocal, you're dividing by the denominator.
Yeah.
Instead of multiplying.
Yeah.
Which is also going backwards, doing something backwards. But reverse sine is doing sine backwards. It's not doing the reciprocal, not doing multiplication backwards. So you just have to be aware that notation is abused slightly in some places, like h to the minus 1 means inverse of h, not 1 over h.
Yeah. Okay.
Because the inverse of h is just not going to be 1 over that, is it?
I guess
As
not.
you'll understand if you remember how to find the inverse of that. How do we find the inverse of any function like that?
So, well, I'm guessing it's not put 1 over it and make it negative.
No. Now you're thinking of perpendicular gradients, which is great. And there's another kind of inverse, sure. But in general, the literal inverse of a function, where you're just swapping x and y around, is where the graph gets reflected in which line am I drawing?
Y equals x.
That's right, which makes sense, doesn't it? If we're swapping x and y around, we are reflecting the pairs of coordinates in that line, so their x and y coordinates get reversed.
Yeah.
35 over, or 8 3/4 and 28 becomes 28 and 8 3/4.
Yeah. Okay.
So, for that reason, the algebra is a case of, first of all, you say, okay, well, that would be y equals that function of x. And the routine then is just to switch x and y. Say x, okay, is y minus 2 all squared plus 1.
Yeah.
Switch them around, and then what?
Then rearrange.
To
find x, to get y on its own.
Yes, we're not finding x then, are we? We're finding y in terms of x.
Yeah.
Get y on its own, I like. Yeah, good. Go ahead.
So x minus 1.
You could say x minus 1 equals
y minus 2 squared. Root x minus 1 equals y minus 2. root x minus 1
Now, by the
2
way, whenever
plus,
when you square root both sides, on one side you should put a plus or minus, shouldn't you?
yeah.
I'm not sure whether we need to now. I think not. I think we'll just take the positive version, won't we? But let's see if I'm wrong in a minute. Because it's a one-to-one situation. Because of that? No, I'm really quite confused. So then y equals what?
Y equals plus or minus root x minus 1 plus 2.
Yes, I'm sure we don't need plus and or minus. Perhaps we should indicate, but we certainly need to decide whether it's plus or minus. I would never have been tempted to think it might be a minus square root there. It's not, is it? I mean, we're going to get something basically that shape. Do you agree that's a reflection in y equals x?
Yep.
Now that's, that is the negative version of the square root. Isn't it? Remember we were just looking back to this one here. There's y equals positive root of x. Down here would be y equals negative root of x.
Yeah. Yeah, possibly. Yeah.
So it must be negative.
Right, okay.
Now, which well, yeah, we're just going to have to face the fact that the algebra is too ambiguous without this specification of which part of the domain we're in. I mean, there's no just straight algebra mechanics which can take care of that for us. We've got to consider the fact that we just end up with, you know, for this part of the function, that part of the parabola is going to reflect to give us the negative part there.
Yeah. Yeah, okay.
So the moral of that is the importance of
just
sketching and interpreting a sketch, as well as...
Yeah.
Oh, and solve the equation. You see, look, we found the inverse of h.
Yeah.
Which are the new y values. It's vital to understand how often the y equals is just implied. You need to know to bring it in so that we're talking about, oh yes, h of x means the y values resulting from this function of x.
Okay.
Okay. So now this question tells us to write what line of algebra?
So our inverse of h, so what we just made, the equation, equals 2. Half equals minus half even.
Yes. But when you say what we just made, you mean just this expression, yeah?
Yeah. Yeah.
I agree. So h1 of x, which is our new y values, which is this stuff, does have to be equal to minus a half. In which case?
In which case, minus root x minus 1 equals
Okay.
minus 2.5.
Yeah. As a fraction?
5/2. Minus
Good.
5/2. And then would you say minus 5/2 minus to the -2?
Oh, but wouldn't things be much easier if we got rid of these negatives?
Yeah, yeah.
And can't we?
Yeah, we can, yeah.
Can't we just actually go like that?
2.5.
Might as well cancel those negatives by making them positives. And now what?
Equals 5/2 squared.
Yeah.
5/2 squared plus 1.
Yeah. So what's that? 25 quarters plus another 4 quarters makes?
29 quarters.
And would that be where 29 quarters, which is what? 5 or 6 or something?
7 1/4, I think.
Right, good. Indeed. So out, as far as that? No, about here. And that's going to be -0.5 on the y value, on the y-axis, which might seem too far down, but that's these scales are a bit skew anyway, aren't they? I noticed earlier when we were talking about y equals x, but it does make sense graphically.
No, you probably are, yeah.